I'm here with Jonathan Witt, the Director of Environmental Programs. Nice to meet you.
Very nice to meet you, Nick.
I have a few questions about Dana Point Harbor's sand and where it comes from, where it is weathered, and how it actually gets here. So my first question is, where does the majority of Dana Point sand come from?
Well, here, even outside of the harbor, I mean, we really have to look at the origin of our sand coming from basically, weathering, erosion, and deposition. So, one point could be right here at the Dana Point headlands. We have various layers. We have the Santa Fe breccia, we have the Monterey Formation, the Capistrano Formation, that through weathering and erosion can then deposit those minerals, those sediments down, and then become a part of the sand layer. But we can also get sand from further north, let's say Laguna Beach, Newport Beach, due to longshore transport as the water, that current is going to be moving that sand in a southerly direction. So those would really be the two main points. And potentially, too, just to the south of us, deposition from San Juan Creek. So we could have sediments, from very far inland traveling to the terminus of San Juan Creek and then being deposited out into the ocean.
And what kind of sediments, like from the rock erosion, is it like? Is it sedimentary, metamorphic?
Well, I mean, it's going to be a nice variety. I mean, again, as an example, with the Dana Point headlands, we're going to have metamorphic rocks. There's going to be sedimentary rocks. So then it's really as those get broken down smaller and smaller into those kind of defined sand particles, it'll be a nice mixture.
Yeah.
So then mineral content too. We might have some mica, or we might have some quartz. So different minerals coming from different processes. So.
What affects the composition in the sand, such as particle size, color, or sediments?
Well, definitely, going back in terms of composition, it's going to be the origin of said mineral, right? So again, it's depending on if it's coming from a metamorphic rock or it's coming from a sedimentary rock. Its raw mineral content is really going to change depending on the proximity of those geographical and geological features. Particle size and also shape can again really be affected by abrasion and movement. There's going to be that abrasion of particle against particle, and again definitely facilitated by waves. So a longer piece of sediment, a mineral, it's kind of stuck in that constant motion of wave action. It's going to become smaller and smaller, and it's going to become finer and smoother and less abrasive and less jagged edges. So, but again, that's going to depend on where you are in the world. And there's areas where there is heavier surf. That process is definitely going to be expedited versus areas where there's less powerful wave action. It's going to take longer to do that.
How does the sand composition and levels differ between low, intermediate, and high tides, if it does at all?
Honestly, I would say it's probably a very minimal difference. I mean, obviously, with a high tide versus a low tide, it's going to be that movement of the mean water line. So, with that, there is the potential for sand to be pushed forward through that wave action, through that over that 6 hour or so period. And here in California, we might have a minimal movement of sand up, and then that retraction back as it's pulling it back towards low tide. But it's not going to have a major effect in terms of composition or levels or anything like that.
During what times of the year do you see an abundance of sea life living in the sand, such as crabs, worms, slugs?
Well, seasonality really isn't going to be a real determining factor in that. It's really going to be dependent upon the actual substrate that those animals need to live in. I mean, if we're talking about whether it's a nearshore or a benthic, an ocean bottom environment, whether it's sand, whether it's mud, the type of substrate is really then going to kind of determine, so to speak, the life that is there, because that's going to then, kind of fan out towards, the idea of adaptation. The animals are going to find the most suitable environment for themselves to survive, to stay safe from predators, to find the food that they need to be able to reproduce and all that. So it's not a real seasonal thing. I mean, we'll see the animals that we know are going to burrow into the sand, are going to be common in the sand, and they'll be there throughout the year. Now, of course, other factors, other environmental factors, other physical processes could kind of change the overall biomass and biodiversity of the area. Definitely, habitat loss or pollution or other strong natural disasters, the type of thing can definitely alter that population. But I mean, those are going to be definitely dramatic and not naturally occurring events.
Do they prefer like a certain kind of sand? Like I know that sometimes San Clemente can have that rocky, more like what's the word I'm looking for? Like rough kind of sand, and then you get other days where it's soft and like easier to walk on. Is there any way that they can live in those rocky environments when the sand is not as soft and they can't dig down?
Yeah, and that's definitely going to be species dependent. There's going to be the ones that won't be necessarily affected. I mean, and you're right. I mean, even that slight physical change to the environment could have a direct effect on the overall population, because there might be those that are very sensitive to that slight change in the environment, and then we're going to see them completely removed from that area, or their population significantly drop. But it's going to be very species particular in terms of which ones are going to be highly affected by a change like that versus a low, just more of an irritation, you can say, in terms of that.
Exactly. How are the ledges or drop-offs on the beaches shaped by changing tide or wind speed?
Well, tides really, again, you have to think of tides in terms of its, that movement of the mean water level from its, low tide point to a high tide point. So there's going to be that swing throughout the course of the day. Here in a semi-diurnal area, we've got basically our 2 high tides and 2 low tides. Those tides necessarily themselves aren't going to have a significant effect in terms of kind of beach slope or those types of ledges. That's really going to be more a direct effect of, again, wave action. So you're right. I mean, definitely, if we're looking at wind-driven waves, right, the heavier surf, the bigger, the stronger surf, that's going to be more movement of that sand up and down and potentially creating those. We'll see that shift, definitely during our summer versus winter seasons. We can say we have a summer beach versus a winter beach.
Yeah.
And they can look dramatically different from each other. Because again, we know when our kind of storm season is, it tends to be during those winter months. So we're going to have potentially heavier surf because we have those atmospheric conditions that are kind of helping facilitate those more powerful wind-driven waves that thus then could potentially move more sand, create more of those features that we don't see versus in the summertime where it might not be as pronounced.
Yes.
Okay.
And then one last question. Does tide height and wave size affect sand's composition or abundance at all?
Well, and again, it kind of goes back to what we were just talking about in terms of, summer versus winter beaches. Yeah. It's going to be a combination of a lot of environmental factors. If we're not getting adequate replenishment, again, through erosion and weathering of those said geological features that are initially contributing to sand right there on the beach, then, the alternative, we might have to actually import it in.
Yeah.
If we're also saying, well, we've got sand traveling from north to south being facilitated by long-term transport, it's going to move down from Newport to Laguna to Dana Point to San Clemente and so on. If there's any interruption, and that's actually a big concern in a lot of areas where we have groins or jetties that are actually running perpendicular to the coastline, because basically we've got the coast going this way north to south, and then we've got a groin or rock wall heading out east to west.
Yeah.
And if that sand's going north to south, they're going to have that pileup on the north side of that rock formation, and that beach to the south could become very depleted and rapidly depleted, again, depending upon the time of the year, if it's heavy surf season, if it's our winter season where we have heavy surf that's really pounding and moving that sand out quickly. So a lot of factors really would contribute to that.
All right, thank you very much for your time. It's really
Absolutely.
appreciated. And I know you have very sophisticated and educated answers, and I can trust your testimony.
Great.
Thank you very much.
My pleasure.